All right, quick video here on chapter 2. This is all about probabilities. In chapter 1, we are picking up the idea of counting items. And so if you know the number of events divided by the sample space, as we would say, the number in the sample space, then you have the probability, okay? So that's a division problem. Number of events divided by the sample space. A couple things, if you are looking at a little tilde symbol, that is the meaning of not. So this would be 1 minus the probability of A, okay? Which means 100% minus some other percentage, right? X%, whatever it is. So it's always what's left over. Again, that means not. All right, compound events. When there are more than one conditional, so you have two events that you're looking for, A or B. Typically, they start off with A or B, and these are independent events, so you can just add them up. But we must, as we move forward, look also at dependent events, which means things like, okay, if I was doing what is the probability of getting a jack or a heart, know that there is overlap here, meaning we have 4 jacks in the deck, we have 13 hearts in the deck, but one of those jacks is a heart. So I can't just add 4 and 13 because I would be double counting the heart, jack of hearts. So in this case, it would be not 17, but 16 because I have to subtract 1. All right, 16 out of, in this case, it would be 52. Okay, and that would be or. If it was obviously jack and hearts, okay, using the symbol there, then that would be obviously there's only one item in the deck that is both of those. So be careful of that. Next, and dependent also affects mutually exclusive, which means two events that don't have a common overlap. In these types of problems, I would strongly recommend that you look at a Venn diagram. So here we have two events, A and B. Maybe A is like you're looking good, and B is the days that important people show up. So in this case, the probability of A and B would be that little football shape, right? That's the overlap. All right. The probability of the orange is the probability of the day of you just looking good. And obviously nobody important shows up. And then don't forget this pink area out here represents the area where you don't look good and nobody important shows up. So there are 4 regions here that you must account for. Okay? All right. And then the next to last idea that we looked at was tree diagrams. And here we looked at probabilities of items. So here you have, for example, the probability of A and the probability of B. Whoop. And then when we look at the next choice that we have, we look at the probability of A, but this is affected by this because one has already occurred. So typically your denominator goes down by 1. And the same thing here. All right, in each of these secondary cases, we have a reduction in the denominator because these are dependent events. All right, and then we can multiply those two together. For example, this would be the probability of A times the probability of A. And those aren't the same result, remember, because the one has already occurred and affected the other. And that gives me my total probability. Finally, we looked at tables. And these are called conditional probabilities. So this means the probability that you like apple juice given that you're a kid. Now, first of all, make sure that in your tables they give you your total columns. If you don't have your total columns, you need to figure those out, as well as obviously any missing numbers here. Now for this one here, we're looking for the probability of that you like apple given you're a kid. So that means you're looking in the kid column. All right, and in this case, you'd be looking at this number divided by this number here. Okay. All right, well, I've posted some problems online for doing a review of Chapter 2. They're extra credit. I'm going to do just a couple of quick problems here. Ben is going in for some oral maxillary surgical program, and he is studying, looks like, and the chances of his being accepted is only 8%. So what is the probability that he will, keyword, not be accepted? So we put the little not symbol in front there, and then again we have to do 1 minus 8%. Remember 8% is 0.08, so my answer is 0.92, aka 92%. And looking at pulling marbles out of a bag. If we have 10 cat eyes in a bag and 5 clearies and 8 swirls and 7 steelies, then we would have, I think that's 30 total. Let's see, 8 and 7 is 15 and 5 is 20, 30. 30 total marbles. So make sure you know that. So then if I look at what is the probability of pulling out a swirly, why that would be 8 out of 30, which reduces to 4/15. And again, steely or swirl, I can add those up. There is no overlap. There's not like some marbles that are both. So 8 plus 7 is 15/30, which is 1/2. All right. Now here, we're taking out a marble, 2 marbles, without replacing it. So this is where that dependency is coming in. So the first marble I pull out is going to be a cleary. What is the probability? The second one is also a cleary. So the first one is not difficult. Again, there are 5 clearies. So 5 divided by 30 times, and now I look at my second probability. There's 1 less cleary because I've pulled 1 out, and there's 1 less marble. All right, and now we would multiply these together, and we would get 20 over 3 times 30 is 90 minus 3 is 87, 870, I think is what I get. Let me double check that with my calculator. 30 times 29, 870. All right, we can see that this reduces down to 2 over 87. All right, well, good luck on your homework problems, and hopefully you can get those extra credit points, and as well as prepare for the exam.